Hi everyone, my name is Esha Gupta,
My name is Meghana.
and our research project is called Air Quality Correlation to Socioeconomic Status in New York City.
We chose this topic because we saw an article that stated that greater exposure to environmental hazards is one driver of health disparities found among communities of racial or ethnic minorities and those of low socioeconomic status. Isha and I wanted to make more people aware about this gap using the data that we found.
Our research is based around one central question. How does air quality compare between individuals across different demographic groups based on race and ethnicity and median household income in New York City? One of our hypotheses going into our research was that individuals who live in areas with lower median incomes will be exposed to more PM 2.5 emissions and therefore lower air quality.
Our other hypothesis is about the correlation between race and air quality. We hypothesize that white individuals will face less PM 2.5 emissions than those from a colored or minority background.
While exploring the literature on the subject, we saw three main points. Research shows that poor air quality has been linked to health problems prevalent in low income and minority communities. And two studies prove that with higher concentrations of PM 2.5 often have a higher percentage of minority and low income residents because these residents are often situated near major roadways and industrial zones.
The data for race and ethnicity and median household income was collected from the US Census Bureau. The PM 2.5 data was collected from Washington State University. Our PM 2.5 data is on a scale of 6.3 to 9.6 micrograms per cubic meter of air. The median household income can range from below $20,000 to above $150,000. The race and ethnicity data shows the percent of colored people for each census tract. Here we made a map that shows New York City's 5 boroughs in their counties. When looking at the scatter plot, there doesn't seem to be much disparity or gap between the low income or high income communities in each county or borough. But by using the trendline feature, which shows the pattern or trend for each graph, we can see that for each borough, the trendline declines as the income increases.
Here we have two maps, the one on the left showing percentage of minority groups and the map on the right showing the amount of PM 2.5 emissions. When looking at these maps, you can clearly see that the neighborhoods with higher percentages of minority groups, such as the area circled in white located in Queens, have higher overall PM 2.5 emissions, and neighborhoods with lower percentages of minority groups, such as the area that's squared off in red located in Staten Island, have fewer amount of PM 2.5 emissions.
We use correlational analysis, which is a method used to measure the extent to which there's a relationship between two variables. Using this, we are able to see an indirect relationship between PM 2.5 distribution and median household income, as well as race and ethnicity percentage. The trend lines in the graph help define this relationship between PM 2.5 and income, because although the graph shows fluctuation on both ends of the income ranges, there are typically smaller PM 2.5 distributions on the higher end. This is seen in Queens, where the trend line declines from an average of 7.55 to around 7.33 micrograms per cubic meter of air. And for Staten Island, the trend line declines from about 7.08 to 6.92.
With this being said, although the extent to which the relationship between all these variables may not be as drastic as we first hypothesized, it still shows a correlation between them. So in order to mitigate the disparity between different ends of socioeconomic statuses, there should be some policies and initiatives put in place to curb the current trend. Some of the most important ones are the green infrastructure projects and the stricter regulations and assessments of air quality. While conducting this research, some of the hardest challenges we faced were organizing the data to make it usable and creating graphics that help accurately visualize our findings.
For the last 5 weeks, I was able to get more insight on how to use numerical data in visual ways. In addition, I love being able to create connections with peers and mentors in our AQI team. So I'm super grateful to have been able to participate in this opportunity.
This hands-on involvement deepened my understanding of data-driven research methodologies. I'm so glad I had the opportunity to work with such a diverse team in order to make an environmental difference.
Thank you, and a special thanks to our mentors.